So now we've talked about what a hormone is. We've talked about how it can move through the body. Now we need to talk about how they specifically regulate different systems in the body. Hormone levels are primarily controlled through negative feedback. We talked about negative feedback in Bio 101. We're going to hit it again now. Negative feedback is where the product of a system is going to go back and interact with an earlier phase of that system. So negative feedback is where the product goes back and stops the whole system. The example I used before was, I think it was birth control. If parents are having kids, a kid is a baby, grows into a teenager that becomes an adult, and that adult does not want their parent to produce any more children. They can give that parent birth control to stop the process. Otherwise, it just keeps going. Think about the Duggar family, right? They're just going to keep having kids until they can't. So if those older children can go out, get some birth control, and bring it back to the top, it stops the whole process. That's negative feedback. So rising hormone levels, as a hormone increases in concentration, it's going to inhibit the production of that hormone. So here we've got A being broken down by enzyme A, B being broken down by enzyme B, and then B gets broken down into an enzyme A inhibitor, which goes back up and stops enzyme A from working, which means the rest of this decreases in concentration. So it's a negative feedback loop. What would positive feedback be? It makes it go faster. So in this case, B may be making enzyme A, which then goes back up there and breaks down A even faster. And we do have that in the body. That helps really build up enzymes extremely quickly when it's needed. So we use hormones to maintain homeostasis in animals. Homeostasis, I think it was like Iana pointed out. Oh, she's dead now. Homeostasis is where you're going to maintain an internal system. In this case, we're looking at body temperature. So for the human body, if your body temperature goes down, what happens to you? What do? You die. You shiver. You start shivering. The muscle movement will cause heat to build up, and that will increase your body temperature. Your blood vessels narrow, so heat gets conserved. If your blood vessels narrow, there's not as much blood going out to your digits, which are going to be very, very, and your out to the skin, where it's going to be let out into the environment. That holds heat in the body and restores normal body temperature. What happens if it gets too hot? You start sweating. Sweat cools you down. Blood vessels actually widen, so there's more blood that goes to your extremities. You'll notice that when somebody's hot, what do their cheeks look like? They're red. Why? There's blood there now. And that blood's cooling, getting cooled down. So that cools the body. So that maintains the body's internal temperature. But we're not just concerned about temperature in the body. We're concerned a lot about water. We have escaped from the seas. We need to survive in a world that is pretty dry. Heck, most of us don't even drink enough water every day. To regulate water levels, we're going to use our kidneys. Now, we talked previously about kidneys. What are they good for? Concentrating waste, turning it into urine, right? Antidiuretic hormone is produced in the hypothalamus, and that triggers the absorption of water by the kidneys, the reabsorption. So water's coming back out of the blood. Aldosterone, which is a hormone produced by the adrenal, I'm just going to read this almost word for word, by the adrenal cortex of the kidneys, enhances sodium reabsorption from the extracellular fluids and subsequent water reabsorption by osmosis. Let me break that down for you, because that's a lot of words. All right, so you have a hormone, aldosterone. That's made by the kidneys. It enhances sodium absorption. All right, sodium's an ion. So if you're increasing the amount of sodium in one area, which way is water going to flow? Towards the sodium. Does that make sense? Water always goes to where the party is. So if you enhance or you increase the amount of sodium present, water is going to flow in that direction. Based on what process? Not trying to trick you, it's right there. Osmosis. So we can control the amount of water. Got to control our reproduction too. This is controlled by the gonadotropins. Anyways, follicle-stimulating hormone, that's the big thing, FSH. It's like fish. And luteinizing hormone. Both are produced by the pituitary gland. So you got these two hormones saying when not only is it time to reproduce, but when is it time to establish secondary sexual characteristics. This follicle-stimulating hormone, this fish, stimulates the maturation of sperm cells. I'm not kidding you. I literally think fish and sperm because sperm swim. That's the way I remember that. And it's the stupidest thing I can possibly tell you, but it might help you. So this follicle-stimulating hormone pretty much says now it's time to develop. Now, sperm are constantly produced through a male's life. Eggs, though, are limited in females. That being said, they are immature, and they're not like mature eggs hanging out in females all the time. The eggs need to mature one at a time. Yeah, Julie's like, yeah, tell me about it. One at a time. It's this hormone that stimulates the egg to mature. Luteinizing hormone stimulates the production of estrogen and progesterone, which are in turn going to control different aspects of reproduction. So estrogen is produced by the ovaries, and it triggers the development of secondary sexual characteristics. It's going to control a lot of maturation of the ova. It's going to control secondary sexual characteristics. Progesterone is going to interact with estrogen to regulate the production of prolactin. So we're getting all of these hormones interacting with each other. What kind of triggering pathway is that where hormones are interacting with hormones? Hormonal, right? I'm not trying to trick you there. So as you get an increase in progesterone, you're going to have milk secretion. You're going to have the acceptance of the fetus, and you're going to have the onset of labor. If you're looking at being in labor being induced, you're going to get given a large dose of a hormone that triggers those reactions to happen. Why does it sound what? It doesn't sound healthy, but people use it all the time. Think about as far as regulating a menstrual cycle. You have to have a regular dosage of hormones. Does that make sense? That's what these things are. They're signals. We got to regulate digestion. Insulin's produced in the pancreas. Insulin is a hormone. As glucose levels rise, you get more insulin. And that signals the cell to either use glucose or create glycogen. Do you guys remember what glycogen is? I think we talked about it a long time ago. Glycogen is used. That's glycocalyx, but close. Glycogen is an energy storage molecule in animals. So as glucagon is released by the pancreas when glucose levels in the blood decrease. So here we got glucose levels decreasing, and that stimulates the breakdown of glycogen and glucose. Breaking that down. So as your sugar level goes up, insulin is released. That breaks down the sugar into glucose. So insulin, the glucose level begins to decrease. The insulin levels drop. As the glucose level bottoms out, you're going to signal the breakdown of glycogen. So you're releasing glucose. So now the glucose levels begin to build back up. As the glucose levels build up too high, insulin is released in order to bring it back down. So you've got this sort of wave going on. You guys have probably heard of people talking about spikes in blood sugar. That's what this is. You can have either too high a blood sugar or too low a blood sugar, but it's all controlled, hopefully, in your body by these hormones. Growth hormone, I talked about my friend who had a pituitary tumor and grew very, very large. The pituitary gland produces growth hormone that causes muscle growth, and it also causes skeletal growth. You get big. Andre the Giant. I don't know. I'm dating myself again. Have you seen The Princess Bride, guys? Yeah. Do you know what I'm talking about, Princess Bride? Yeah. Oh, thank God. Yeah. Fezzik the Giant had a pituitary issue where he was constantly producing growth hormone, making him very, very large. Increases a lot. Yeah, and skeletal too. It changes behaviors. Short-term stress. So stresses that you're getting right at the, how can I put this? You're scared. Right. Did you say a test? Yes, short-term stress test. Seems like that's your whole life, though, doesn't it? It's not short. Now it's chronic stress. This leads to the release of epinephrine and norepinephrine, which triggers the flight or fight reflex, or fight or flight, one of the two. Pretty much, you're going to build up a hormone that then in turn signals heart rate to increase. What does the increased heart rate do? Heart rate goes faster, so what's happening to your blood? Blood's pumping faster. Your breathing rate increases. You're increasing the amount of oxygen getting to your blood. That blood is getting out to your cells. Your cells are now able to produce a lot more ATP. Blood pressure goes up. Glucose levels spike. You're getting more energy. The rate of glycogen increases. The rate of glycogen breakdown increases. Your body's giving itself sugar. It's giving itself a lot of oxygen, and it's saying, produce energy fast, get out. Or produce energy fast, beat that thing up.